basically we're going to go through the stages of making a 2D Unity game. And this is kind of like going to be a ground up from basic resources of like sprites and images and audio and things, then building it all together in Unity. And then by the end of the day, you will have a game which you can play in the browser, play in the Unity player, then build it to like Windows 8 or Windows Phone or Windows Tablet, basically any of these things, and push it to those devices. And this training is going to be split up into a couple of sections. So the first section we're going to go through now is mostly sort of like the setup and familiarise ourselves with the 2D tools and how Unity sort of changed a little bit. Then we're going to have lunch at some point when I guess the smell of pizza arrives, if it's pizza. I'm building up your hopes up, right? And that's when everyone eats all the pizza then leaves, right? Then after lunch, I'm gonna do like a little 45-minute, 50-minute talk showing people how to build to Windows phones. That's when the porting guys can come back and see that. Then we'll carry on 2D training. So kind of it's going to be split up into sections, but by the end of the day, we'll have a 2D spaceship shooter, asteroid exploding game with missiles and sound effects and lots of cool stuff. So each time I talk to a crowd of people, I like to know who I'm talking to. So who here is a programmer? So just put your hand up. Okay, cool. Who is a 3D or 2D artist? Okay, a couple of people. Who has used Unity before? Okay, who doesn't even know what Unity is and they just like, okay, cool, at the back, and has just come and saw a bar that was open in the morning at 9 o'clock. He's perched on the bar as well, so he's at the right point. Okay, cool. So who here's a student? Okay, a couple of people, that's cool. Who's used Unity for years and years and years, but wants to learn the 2D stuff because it's like a new thing? Okay, that's cool. Okay, that's awesome. So, yeah, let's get away with it. Awesome. So, yeah, I'm a product evangelist for Unity for Europe, Middle East, and Africa. That's me jumping out of a plane. So basically, it's my job to go travel around these areas like Europe and then spread the love of Unity, show off new features, run workshops, run trainings, basically interact with the community, everyone from like students who want to get into Unity to like big experienced teams, and basically see how they're using the engine, how they could use it in the future, and basically talk to them about, you know, how all the tools and features in Unity. I'm on Twitter and I sort of post about Unity, take pictures of my cat, moan about the weather in London. Oh yeah, so there's going to be a lot of British jokes. That's sort of like a disclaimer I should put up here first. A lot of terrible jokes. So yeah, I also have an email. So if you guys want to contact me afterwards, like want to talk more about the 2D tools or talk about other Unity bits and pieces, or you've got a cool game that you just want to, you know, send and say, hey, do you have any advice, or have you seen this? Like I was talking to some guys. Has anyone seen like the Dolphin School Simulator on Oculus Rift? Or has no one seen that? Someone's made a game for the Oculus Rift where you put your head down and you have to peek at other students' exam papers to cheat on your test, but everyone's a dolphin. And yeah, I was just talking to those guys, just seeing how they did bits and pieces. So yeah, if you have any cool games, send me an email or on Twitter, and yeah, and I'll be wandering around, so just grab me and talk Unity, because that's what I do. So what we're going to learn, so we're going to learn a whole bunch of bits and pieces. So those of you who have used Unity before and dabbled in it, you might be sort of like sucking eggs a little bit at some point, which basically means that I'll be covering ground that you might already know. So for example, audio, I know what an audio source is and things like this. We may be covering ground like this. This is aimed at like a ground up thing. So those people who have never made a game before in Unity, we're going to go up. But there's going to be lots of new bits and pieces as well. So I'm going to go through the editor and layout, how it's changed with the 2D tools and how you can interact with it, how to import sprites, how to cut up those sprites from like an atlas, how to render those sprites, 2D colliders, 2D physics, 2D specific scripting, 2D frame animation. So the animation window has now changed like a bit in the latest version of Unity. So basically, I'm going to be going through that. I'm also going to be doing a little bit of, I would normally write mechanism there, but people get a bit scared when they look at mechanism because they assume it's like a highly complex bipedal animation system for like parkour games or 3D third-person games like Assassin's Creed or GTA or something. Whereas you can actually use mechanism for just standard animation. So we can use mechanism to drive 2D animation. We're going to do some sort of basic audio things. We're also going to do keyboard inputs versus mobile inputs. Now, one of the sort of like main aspects of Unity is the fact that you can author your game once and then deploy it to wherever you want. So you create your game on the editor, bring all your assets, and then you can then publish it to multiple platforms. So in the hour talk I'm going to do straight after lunch, I'm basically going to take a simple game and then push it to Windows Phone and Windows 8, basically without changing any of the code, and sort of talk about the differences between the platforms and things you need to look out for when you're building for Windows. But it's fairly straightforward, and it's a lot of looking at a loading bar building things. So yeah, and platform defines, and GUI, and, well, the old GUI text system, and there's probably lots of other bits and pieces, but I don't want to just flick through about 20 different slides, because that's pretty boring. We want to make some cool games. Cool, so Unity is a 3D development engine, and that's kind of like how it's been for like quite a while, where people create games that are 3D in the engine. Now, it reached a point where people who wanted to use our tools and wanted to use our editor and things like that wanted to make 2D games, but those native 2D tools weren't there, so some people have made plugins or extensions of the engine. So, for example, does anyone here use 2D Toolkit or Sprite Kit from the asset store? Okay, so there's plugins that people have written that built on top of Unity to render 2D things. So for example, so everyone knows this game, right? Do I need to introduce Angry Birds to... No? Okay, cool. So basically, Revia used Unity to make Bad Piggies, and they tricked the engine to kind of like rendering 2D sprites and things like that. So they built and extended the editor for that use. There's a game called Tesla Grab, which is, I think it's out on Steam now, and it's being released on tons of consoles. But they made that using their own 2D system. Then we released our 2D tools, and when the developers said, cheers, we just spent all this time and investment into making our own 2D stuff. And what they did is they tried it out with our 2D tools and tried it out with their 2D tools, and they found that our 2D tools ran, like our physics, basically ran twice as fast as theirs, and they're getting much better performance. So they're now shifting the whole game over to our 2D tools for release. There's lots of other 2D games. There's also games which mix 2D and 3D together. So one example would be like Doom or Minecraft. Obviously, those aren't made in Unity. But basically, they have 3D environment with 2D sprites rendering either for enemies or pickups and things like that. You can do all this in Unity. So with the 2D tools, you can make 2D games. You can make 2D and 3D games, which is what we're kind of going to do. And you can also make 3D games. And it's very mix and match in sort of how you make those. Cool, so yeah, it's been a 3D development engine, but with the release of 4.3, which is like a couple of months ago, we have a whole bunch of native 2D tools in there. So is anyone not on Unity 4.3? So you all have the latest version, up to date. Yep, that's good. We'll soon find out when people look for 2D tools and it doesn't exist, because they're on 4.2. So basically now there's a whole bunch of 2D tools, and we're going to go through that process. Groovy. So let's do that. So do you all have the source files, like all the resources, 2D workshop files? Say now if you don't. Okay, that's cool. So the Microsoft guys, you've done a cracking job. So if we look through that file, we've got a whole bunch of bits and pieces. So some of you are probably very nosy and have looked through already. That's okay. So we've got a couple of sprite sheets and a couple of simple sprites. So we have asteroids, we've got background of space, we've got a sprite sheet explosion, we've got a collection of spaceships and one image, and we've got like a rocket, like as a grid. So you can kind of tell what game we're going to make, right? We also have a texture of Venus, which is modeling very nicely for us there. We have a font. We have 2 clips of audio, so we've got like a background track, and we have a sound effect as well. And we've also got some app icons. Hello. Yeah. Okay. Do you guys have the USBs? I've got one somewhere. Oh, everyone's got USBs. So these, some go, oh, we've got like a box of like hundreds. Okay, cool. Okay, cool. So inside those, so whilst those people are, I'll point out some other things. We've also got a series of app icons. So by the end of the day, you'll know how to build a game using the 2D tools, build a game in Unity, those who never made a game before, which is quite cool, and you'll know how to build that game to Windows Phone and Windows Store. So those of you who want to take this game, it's going to be very sort of like a lightweight type, shoot things and get point type prototype. If you want to then take that and build on top of it, so add extra sound effects, add extra animation, you then can do. I've supplied very nicely a couple of logos for you to use. So we've got a Windows Phone icon, so we've got the asteroid logo. We also have some Windows Store icons, so we have all sorts of different types of Windows Store icons to fit into the Metro interface. So for example, in the Metro interface, like Drazen demonstrated earlier on, you have all these sorts of tiles. And you also have your big long list of apps. So I've supplied basically an icon for this size app. I've also supplied a variety of different size icons for different sizes of tiles. So you'll notice with the Maps icon, if I dock that here, if I right-click the Maps icon, currently it's in medium mode. And if I change that to be like to small, basically it's going to swap out, get rid of text. It's going to use a smaller image. If I resize that, it doesn't have a wide one. Okay. Okay, the desktop has a wide one. So what you'll notice is if the desktop goes to medium, basically it's going to crop it and change sort of that interface based on how big it is. And that's what I've given you guys. I've given you a folder with all sort of like different size tiles. So you should all, if you're on Windows 8, if you're on a Mac, this might not work if you're building to Windows 8, unless you're running like Parallels or Boot Camp like I am. So yeah, I've supplied a couple of icons. So those guys who didn't have resources, have you got them all now? You've got a nice picture of Venus and some spaceships? Maybe? Okay, cool. Right, so let's begin. So we're literally going to build a brand new Unity project from the start. So if you open up Unity and create a brand new project and save it, I'm going to save it onto the desktop. And you can call it, I'm going to call mine Asteroid Blast, just to be very creative. So file, new project, and then set up a brand new project from scratch. So is there anyone here who's never opened Unity before? Like it's a completely brand new thing? Okay, that's cool. I'll talk about basically how Unity works in a second. So Helsinki, Asteroid Blast. So just create a brand new project and create that. So the way that Unity works is when you create a brand new project, you have a series of folders which you can then all use. So if you have a look at your file structure for Unity, so if you go to that Asteroid Blast, you have 4 files. So if you have this project open, you basically have a temp file. I wouldn't recommend poking around in there. You also have a project settings file. So the project settings is kind of all the backgrounds things. So how you set up your physics and which direction they go, or how you set up your inputs and things like that. But Unity tends to update those as you change them. You also have a library. I wouldn't delete anything from that because things go funny. And you also have an assets folder, which is completely empty. So the assets folder is kind of like your link into the Unity project, and it's where you import bits and pieces into. And the assets folder is very useful. It's kind of like where you bring all your images or your audio and all your fonts and all your bits and pieces in. So if you close the Finder and you go into Unity, one thing that you can do is, who's on the default layout that looks a bit like that? Okay, it might be useful. Okay, I'll stick to this layout for you guys. Cool. So down the bottom here we have our project where we bring all of our assets and all of our bits and pieces into. So there's a couple of ways you can do that. You can just drag and drop it into that assets folder that was created, or what you could also do is take the 2D Workshop resources and just simply go in, select all of them, and drag and drop them into the Unity project. So like so, and that will just have a little loading bar. Basically import all the audio. So you don't have to go through any hoops and go file, import this particular file. You can just drag and drop it straight in. And what we should have here is we should have exactly the same file structure, exactly the same files as we had like in the imported assets. So we have everything in Unity. So those of you who've opened Unity before are probably like, yeah, okay, get on to the awesome stuff. But it's very quick. I showed a guy this the other month, how easy it was to bring in items, and he was like, what is this black sorcery? And I burst out with laughter. But yeah, it's very quick. You can just, it's very quick workflow into bringing things in. Awesome. So we have all of our assets. So the first thing that we're going to do is have a look at the interface. So what you'll notice is that we are in Unity 4.3, and we have a whole bunch of 2D tools accessible. Now, the Unity interface has hardly changed at all. It's fairly familiar to how it was before, other than this little 2D button at the top. So this 2D button basically swaps in and out to a 2D scene editor. So in our scene, we build up our game, we bring in all of our trees, we bring in all of our roads and enemies and players and things, and ticking that little 2D button basically then locks off the axis. So if you try that out, you can notice that it goes from a 3D perspective into a 2D one. The little gizmo does a weird iOS 7 fade out in the corner. And you can basically switch it into 2D mode. So the 2D tools have been made so that you can create games in 2D or 3D, or 3D and 2D, and mix and match them in development. So at Unity, we don't like to release an engine or an editor that basically says you must make a hyper-realistic racing game with accurate terrain destruction, and that's all you can make in our engine. What we tend to do is we tend to keep it quite open so people can be very flexible with how they make games. And there's a whole range of games made in Unity that cover a whole range of genres. And with the 2D tools, we didn't want to pigeonhole people and say, you either make a 3D game or a 2D game, because that wouldn't be sort of how Unity's been built from the ground up, and that's very open. So with these 2D tools, at any point in the game, you can say, just turn on the 2D scene viewer, go in and edit your scene all on the X and Y axes, but then you can switch it back out. So that means you can use 3D objects in your 2D game, you can use 2D objects in your 3D game, you can basically mix and match it. So say like you're making a 2D game, like a platformer, and halfway through development you say, oh, it'd be quite cool if all the trees in the background were actually 3D meshes. That'd be quite cool. You then don't have to start your project from scratch, re-import all your things, re-import all your code, make sure everything lines up. You can just toggle on and off to then bring in some 3D trees, position them, and then toggle that. You can basically mix and match it how you like. Awesome. So what you'll notice is that the game, if I just make a simple cube, like so, because everyone, when they make a game, starts off with a cube. What you'll notice is that when we go into 2D mode, it basically locks off that axis so you can move that cube around in X and Y. And if we go to our game view on our camera, our game view is still in perspective mode. So you can make a 2D game either in a perspective mode, so you have parallax scrolling and things like that, or in orthographic mode, so everything's locked off. So what we're going to do is, if you go to the scene view and go to the camera, what you'll notice is that we have a cone, like so. Right, okay. So, yeah, apparently it's a bit difficult to see from the back there. So I can always use a magnifier and basically zoom in onto particular bits. So we have our cube like normal, and what I'm going to do now is I'm going to delete my cube, and we're going to do everything in the 2D scene view. So when bringing in textures and sprites, so if you go down into your project, you have your little sprites folder, and we've got a series of things. We have asteroids, we have some background space, we have an explosion, we have a rocket, and we have some spaceships. Importing in these textures, they don't automatically turn into sprites. You have to turn them into sprites yourself very manually. So if you select BG_space1, what you'll notice on the far right-hand side under the import settings, so basically in the top right-hand corner here, we have different texture types. So if you bring down that drop-down, we have a texture, we have a normal map, we have a GUI, we have Sprite, we have cursor. We've got all sorts of ways that we can bring in our texture and import. Now, the one that we want to use is going to be Sprite. So under BG_space1, we want to select Sprites, and we have a couple of options for bringing our Sprite in. So we can either bring in our sprite as a single object or as multiple. So multiple will be useful for things like an atlas, where you have a series of images all within one image, or you have just one single sprite. Now our background, if I zoom down to look at it, our background is simply just one big image of space. So we're going to import this as single. Now we have a packing tag as well. We have pixels to units, and we have pivot, and these are all things I'm going to talk about a bit later on. But now that we have our sprites set up to basically come in, we need to click apply. So what it's going to do now in our project folder, where all of our assets and all the things are stored, is turn our texture into a sprite. And with that, we can just drag and drop it into our scene in the middle, and we have a big image of space. Cool. Has everyone got that? Okay. I'll switch you to this view. Shit. Okay, so we have our background there. And now when you select an object, basically it shows on the site lots of information and properties about it.
So you open it from there?
Yeah, you just select it there. We're going to import it to a sprite, and we can click Apply. So what we're going to do now is currently we're in the 3D view of Unity, and if we click that little 2D option, it basically snaps into 2D mode. And we're then going to take the sprite and then drag and drop it into our scene, so we now have a sprite there. Cool. Awesome. Okay, cool. So we now have an image of background rendering in our scene. Now, this is quite a bit different to using a 3D object. And I'm probably going to say the word overkill a fair bit during sort of like this day. And the fact is we didn't want to use 3D rendering system for 2D sprites. Because if you have a game, for example, Candy Crush, there's lots of sprites all layered on top of each other. And rendering all those with a 3D system would basically be very intensive to the phone. And basically very bad, because 2D games tend to have lots of sprites all around the edges, all with different depths. So if you select the sprite, so if you go to your hierarchy on the top left of all the things within your scene, and you select the sprite, on the right-hand side in the inspector, you're going to see that it has a transform, which is basically its position, its rotation and scale, like where it is within the scene. And we also have a sprite renderer. So the sprite renderer is in place of a mesh renderer, which is for 3D objects. And the sprite renderer is kind of like the message the renderers say, this is not 3D, this is actually 2D. Now, if you toggle the little 2D option at the top here, so yeah, just at the top here along the top of the scene view, what you'll notice is that when we swap in and out of 2D and 3D mode, basically we can still use our 2D sprite within the 3D environment. So I could make something like Doom and have all my enemies as 2D sprites. But I'm not going to do that. I'm going to switch to 2D mode. Let's unify that. Cool. So if we have a look on the far right-hand side, we've got a couple of things under the sprite renderer. So the way Unity works is it has a series of components. So every object kind of like has a series of components to describe what that object is like. So for example, I'd have a component saying of my hair, saying it's brown, it looks like Tintin's haircut, it has all sorts of things about it. I'd have another component say how tall I am. Basically, a lot of components to describe up our objects. So this one has a coordinates within our scene. It also has a lookup to the sprite that we're going to use. It also has a color. So in the 2D system, all of our sprites are independently colored, so you don't have to make a separate color for each sprite. So if you click the little color icon, so click the little color drop down, sort of like the little white box area, you can basically now tell your sprite to be a different color. So if you had a blue car, you could then tint it slightly darker in Unity. If you had a white car, you could tint it as red. So someone shout out a very pretty color, as long as it's not blue or white. Has anyone got a color? Okay, pink. You've all asked for this. Cool. So if we now change the color to pink, basically it's going to change the color of that sprite independently. So if I zoom in, what you can see is pink. And as I change the color, it's basically going to do an overlay and tint it. So it doesn't recolor the whole thing. It takes what the original image is and basically recolors it based on what color we've picked. And that automatically goes to the renderer and says, we are now a pinky background. Actually, I'm going to go with pink now because no one picked a color. It's my go-to color. Awesome. Cool. So we now have a pink sky. So what we can do now is we can look at the game view. So the game view basically says, the scene view is kind of like the Sims house building system, where basically you go around, you drag and drop plants and buildings, and you build death traps for your Sims and things like that. Whereas what the game view is at the top, along the top window, is basically how your game's going to look at the end. So this is basically saying, when we play our game, when we push it to an app store, this is what our game looks like. So if we, in the scene view, we'd have like a top-down view, we'd have all the different bits and pieces of our game, we can fly around and interact with them. Whereas if we were making a first-person shooter, if we went to the game view, you'd probably see what the guy looks like, his little gun, his like ammo in the corner, and all sorts of things like that. So let's go to the scene view. So what we notice here is that our game view is basically going to be very different. We haven't got a full screen background into here. So what we need to do is we need to switch our build platform of what we're targeting. So in Unity, you basically build your whole game, and then you choose what you're going to build to. So if you go to File in the top left-hand corner, and go down to Build Settings, so File, Build Settings, and select that, we have a drop-down list of all the different things that we can make. So if we're making a web player game, we can select that and build a web player. If we want to make a Windows Store app, so like a Windows 8 app to go on the Windows 8 store, we basically select that and build to it. Or Windows Phone, we select that and build to it. You can see like a recurring theme with this selecting and building business. So what we want to do is we want to make our game so that it's not like a full screen game as it currently is, and it's going to fill the whole scene. We want to basically prep it so that we're going to make it for Windows Store. So if we select Windows Store apps, we can then click the little switch platform icon. So what you'll notice, there's a little Unity icon next to which platform that you're going to build it to. If you go down to Windows Store apps and click switch platform, basically that Unity icon is now going to snap into what we're going to build to or what we're going to target. And it does it almost automatically. There might be a little loading bar, but it basically just swaps it in. So we're going to select Windows Store apps because we're all on Windows 8.1. So basically we're now going to build to a Windows 8.1 app. So that's cool. So if you then close that window, what we can then do now is you can basically fill our background to fill our entire screen for our app. But what we're going to do next is, we're going to do that. So if you select the background, what we can do now is we can grab the different handles and resize it. Now, it's going to be a bit tricky to swap into the game view, go to the scene view, go to the game view, and back and forth. So what you can do is you can select the game view window, and you can basically drag out the window and basically move it wherever you want, just like the Windows 7 and now in Windows 8 snap feature. So what you can do is we can select that tab, and we can position it next to where our scene is, so we can basically sit things next to each other. So just grab that little tab and just drag and drop it to where you want it to go. So I'm going to drag and drop my game view there. So now we can see what our player is going to see in the end, and we can see what is within our scene. Very handy. Cool. So obviously our background's not going to fill the entire game view, and currently we have this like light blue background that our game's going to look like. So what I want you to do is I want you to basically drag the scene space to wherever you want. Now what we could do is with the 2D tools you can basically select the handles and resize them automatically, like select the corner and do that. Or we can edit the scale properties in the corner. So whichever way you feel best, so click the corner of the 2D sprite and basically just resize it massive if you want. So basically we now have a large area of space, just filling up our whole scene. So it's pretty huge. Everyone okay with that so far? Simple stuffs. So if you go to File, Build Settings, we have Windows Store Apps. If you select that, no, click Switch Platform. So basically what it's going to do now is it's going to say we're not going to build this for PC and Mac at the moment. We're going to build this for Windows Store Apps. Basically it's prepping it for the future. Cool. So we now have a big space. So one of the cool things about Unity is you don't have to just build every time you want to test your game. You can run it all in the editor and see it all doing bits and pieces. So if you click the little play button just at the very top, basically it's going to dim sort of like the display. The little play button is going to turn blue, and our game is now running, and it's the most interesting game in the world. So if lots of this game of just a simple space background is published to the Windows Store, I know exactly where it was made. And you can all credit me, right? Yeah. So what we can do is we can basically, when we bring in our spaceship and we start flying it around, we can basically click the play button, test out our game, unclick the play button, carry on building our game. We don't have to build it every single time. We can make a whole game in Unity and test the whole thing, and then just build it right at the very end if we want to. Now, in our game view, which has like the little Pac-Man icon at the top, in our game view, we can basically have a couple of options. So we have different types of aspect. We also have maximize on play. So maximize on play is very useful for a Windows Store app, because Windows Store apps tend to be very full screen. So if I then zoom out of that and I go into Windows Store, so let's just pick, I don't know, IE. So what it does is it's going to maximize the app to the full screen. It's then basically going to fill your whole view. So using maximize on play is a good idea in Unity to see how big basically your game's going to look like. If I just get rid of that. Awesome. Let's go back to Unity. So if you click maximize on play, which is at the top here, click that. Then click play. Hang on, I'll zoom out. Basically, we can now see that our background has basically filled up the whole view. We have a nice big image, and this is kind of going to simulate what our Windows game is going to look like, which is fine. It's a very interesting game. You can't interact with it. It will make for a very nice wallpaper, I guess. That's pretty much it so far. But we're going to have all sorts of things running around in the background and firing missiles and that. Awesome. Cool. So, what we're going to do next. So the next thing that we're going to do is we're going to bring some spaceships. We want to bring in some interactivity. Okay. If you close that. So what you notice here is we have two tabs.
Yeah, I tried that, but it's another screen.
Okay, if you click that and drag it, you can basically move it and snap it to wherever you want. So you can basically sit what your game's going to look like next to making your game. So you can see, oh, okay, our space isn't going to fill the whole view. And now we can go... Awesome. So we're going to kind of make the game all in this view and then like preview what it's going to look like in this view. Cool. Awesome. So let's put some spaceships into our nice pinky space background. So if we go down to our project to the bottom, to all the bits and pieces that I've given you guys, and you select the spaceships texture, what you'll notice is, if I zoom in, at the top here, we have the option to turn our spaceships, to select the spaceships in our project. And on our inspector, we're basically looking at all the things about the texture. We're going to set it to be a sprite to begin with. Then we have two different sprite modes. So one's single and one is multiple. So what we can notice from that little thumbnail is basically it's not one big sprite. It's a series of sprites. So what we're going to do is we're going to switch it from single to multiple. So select multiple. And we're going to click apply as well. So if you go single to multiple, then click apply, what it's going to then do is it's then going to prepare our sprite sheet ready to make a series of spaceships. Cool. So the view that we're going to use now is a sprite editor. So if you click window and you go down to sprite editor and select that, what it's going to do is it's basically going to open up this window for us to then tweak and build our sprites in. So I'm going to make my sprite editor window pretty big. I'm just going to dock it underneath where the scene view is. So we oh, hang on. Okay, cool. So if you just go Windows Sprite Editor, then dock the Sprite Editor somewhere here, what we can see when we select our spaceships is basically what our sprite sheet looks like. So this is a PNG. It's basically got a series of spaceships. It's transparent, and it's got the transparency around the side of the spaceship. So you can see that with the white and grey squares. So what we can do in Unity is instead of, for example, bringing in 30 spaceships as all completely different textures, and that way you've got 30 extra files in your game, and you have lots and lots of files in there for your build size at the end, which is going to be massive. A lot of 2D games, like Candy Crush is a prime example, have tons of sprites all layered on top of each other, all at different positions. So basically, our 2D engineers said, I know, why don't we just have a system where we can go into a sprite editor, bring in this sprite sheet of all these ships, cut them all up, and then use them all individually. So basically, we're then going to slice up all these ships for use. So inside our sprite editor, we can use the little toggle handle at the top. So if I zoom in, basically we have a little toggle handle that we can zoom in and out of our sprites. We also have some handles along the side. Let's go there. We also have a couple of handles along the side. And what we can do is we can then click anywhere within our sprite sheet and drag out a green box. So can you guys see that green box? And we can drag out a green box to wherever we want it to go. So this box is basically going to be one slice. Where basically, it's like if you get pizza, you don't eat the whole pizza in one go. You cut up the pizza into different pieces and eat it individually. We're kind of sorry, I really like food, and we have pizza later on, I guess, I think. So yeah. So what we can do with this box is we can position it where we want it to be, and we can say, this is a sprite, this is a sprite, and this is a sprite. So what I want you guys to do is, just for a bit of customization, if you click somewhere within the scene and you just drag within the sprite and just drag it out, you'll drag out a box. So with this box, we can basically select inside it and move it around within our scene somewhere, within our sprite editor somewhere, to basically select one of these sprites to be our ship. So what I want you to do is I've supplied you with, for, I don't know, 8 ships, I guess? No, more than that. Sorry. I've supplied you a selection of ships, and I've supplied you with a selection of weapons. I want you to pick a particular spaceship, and I want you to then drag that box to wherever the spaceship is, and basically resize that area to basically capture in that spaceship. So basically tie it all together, so neaten it up a little bit. So I'm going to pick this green one at the top here, and you guys can follow along if you want, or you can pick a different one. Cool, so we should have a nice box around a particular spaceship. Cool. So what we're going to do now with this spaceship is basically say apply. So those of you who use like version control, what you can do is you can do a commit. So basically say when you make any changes within your file, you then commit it and push it for other users to pull. And that's what we're going to do the same thing. So what you'll notice down here inside our little project, inside our project folder, is underneath the background, we have one sprite slice. So basically our background space is now kind of like a drop-down list with only one item in that list. Underneath the spaceships, there's currently none. Now what we can do is we can cut up several of these spaceships. So what I want you to do is basically, as well as get that box and align it around a particular ship, select a different one and draw another box around it. So I'm going to take this spaceship, for example. I'm going to basically say, this is the next spaceship. You can select more and more. You can basically go through all the sprite sheet and cut up lots of individual cuts. So if you just have 2 spaceships at the moment, what I want you to do is right at the very top, we have this little apply button. I want you to click apply. So what apply is going to, okay, we're not going to click that. So what apply is going to do is it's basically going to say, these are the cuts that I want, these are the sprites that I want, and this is what I'm going to use in my game. So clicking apply, what you'll notice now in the bottom left-hand corner in the project is underneath space we still have that one slice because we're using one sprite. Now as we set this as multiple sprites, basically you can get this drop-down list and you can see that we basically have 3 slices now for this one texture. So this workflow is very good because what you can do is you could have your artist draw out 30 buildings, bring it into Unity, slice them all up. If he adds 5 more, you can then just go in, slice up the next 5, and basically you just keep slicing up as many buildings as you want. So we now have 3 different types of spaceship. And what you can see as well in the bottom right-hand corner is as I go through these different ships, and I've even selected like a bit of a spaceship, I guess. Yeah. What we can do is we can select each of these sprites and basically say, see what they look like in the end, which is quite cool. So we can say this is a ship, this is a ship, and this is a ship. And we can use those individually. We can then drag and drop them in the scene, and basically say this is the sprite that we want to use for this particular object. Now we come to the problem of a sprite sheet like this. So a sprite sheet like this is very, very complex and very, very complicated. It's very complicated in the way that basically there's lots of bits and pieces to it. There's lots of things all over the place. And if I was to sit there and say, right, I want you guys to slice up every single spaceship and every single part individually, this would take ages, right? And I feel sorry for any developer who gets given a sprite sheet of 1,000 sprites and then on a Friday evening when they want to go home, and then the artist leaves and then the developer's there just slicing up sprites and going 1, 2, 3, and slowly falling asleep. So what our 2D tool engineer wizards did is they basically say, we want to make people's lives easier, because at Unity, basically with our tools, we want to make it so that game development isn't such like a chore, and basically it takes out sort of the hardships of it and makes it slightly more streamlined. So at the top left-hand corner here, we have this little slice button, and it's fairly small. And if we click that slice button and open that up, we basically have two types of automatic, where we have automatic slicing and we have grid. And these are fairly self-explanatory. So automatic is basically going to go through, it's going to find all the sprites, and it's going to cut them all individually for you automatically with one click of a button. So I could have been really mean and got you guys to cut up every single ship independently, then told you about this, but I figure I won't be that mean. So we're going to select automatic. If I zoom out, once selecting automatic, these settings are all okay, we're going to click slice. So after you click slice, what you'll notice in our scene, in our sprite editor, is basically we now have lots of different cuts around every single ship. And what we can do is we can select this ship, we can select this ship, and basically it's cut them to be a best fit and go around them. It's pretty cool. Everyone okay with that so far? We now have lots of spaceships all cut up. So now that we have all of these slices all made, we need to go to the top right-hand corner and we click Apply. Because every time we make some form of cuts or make some form of changes to the sprite sheet, we need to basically tell Unity, we're happy with these cuts, now cut them up and basically save them for our use later. So we need to click Apply in the top right-hand corner. So now what you'll notice in the bottom right-hand corner where our project is, hang on. My mouse is going funky. What you'll notice is that we now have 27 spaceship sprites. And what you can do is you can basically now select each ship, and you can see in the bottom right-hand corner of the inspector, every ship all automatically cut up, ready for us to use in our game. It's even cut up like the little laser blasters, which we're going to use as well. But yeah, we now have all of our spaceships all cut up. Very nice. Everyone has got a massive list of spaceships. Okay. You have 35 spaceships. So either you very quickly, you're a very good pixel artist, you've just drawn some more content, or something has gone a bit funny. Oh yeah, that's fine. I intended for that to happen, don't worry. As long as you have whole spaceships, that's cool. I'm going to talk about those bits in a second. Yeah, we have to manually do like one of them in a sec. That's okay. But you have, if you select down here, you select a different one. Probably the higher up ones. If you scroll up a bit. Yeah, you've got some, keep going up. Keep going. Keep going. Yeah, there we go. So we've got all our spaceships ready for use. Cool. So we now have a whole stack of spaceships. That is pretty small, I'll admit. Okay. I'll zoom in more in future. So what you'll notice is it's basically taken the name of spaceships and it's just numbered all of them individually. We now have 27 spaceships. So like before I worked at Unity, I worked at a university, and trying to mark students' work all called untitled is probably the hardest thing to do in the world, because everything is untitled, or everything is like, everyone puts foo for every variable name, and yeah, it's a nightmare. trying to mark all this work. And I'm a bit of a stickler for naming things correctly. I like to, background space, I know exactly what that is. I know what asteroids are. And I'm not happy with the fact that it's now spaceships 0 to 27. So if I said to you, pick out the orange spaceship that looked like a bat, you'd have to go through all this individually and find out which one it is, which is a nightmare. So what we're going to do is we're now going to name these, or rename one of the spaceships. So, oh no, we're not going to go into this. We're going to rename one of the spaceships. So what I want you to do is I want you to pick a spaceship that you're going to use. And it can be any of them. It could be this massive one in the top left-hand corner. It could be this tiny little green one. It doesn't really matter. Basically, just pick one of the spaceships. And what I want you to do, so I'm going to pick this one in the top right-hand corner here, is I want you to select that slice sprite. So select that little cut. And what you'll notice in the corner here is it basically says all the things about this cut. So if we wanted to change the position or change the pivot and things like that, we can do that. But another thing that we can do is we can also change the name. So I'm going to pick the green ship. So I'm basically going to say, you are no longer spaceships _3, which sounds horrible. You are now green spaceship. Cool. So what we have to do every time we edit from here is just type in the name, click apply in the top right-hand corner, and then after we do that, basically what you'll notice in our big drop-down list of 0 to 27 spaceships, or 0 to 35 as the pixel artist over there has got. Someone hire that guy for quick artwork if you want a quick turnaround and fast development. What you can do is you can basically scroll through and you'll notice that it's now highlighted green spaceship. I don't have to sit there and go through all my sprites to find out that is my spaceship. Nice and easy. So who's picked the same one that I've used? And, right, you're a copycat. No, that's cool. You can pick whichever one you want. Who picks the bat-like one? No, no one likes that one. Okay. Who picked the massive one in the top left-hand corner? No one. Okay, that's cool. Right, so we have our green spaceship. That's cool. We're going to have this flying around in a second. So what I want you to do is we're now going to leave the sprite editor, and I want you to click Scene. So we now have our scene view here, and we have our camera, and we have our background. And I want you to take your green spaceship, so select your green spaceship in the little project, or whichever spaceship you've chosen, not the orange bat one, because no one likes that one, apparently. And I want you to drag and drop that into your scene. And what you should see is you should see a little plus symbol. And once you drag and drop into the scene, we should have a tiny little spaceship that's like basically the smallest thing ever. So yeah, we have our we're making a game based on The Borrowers or something. Awesome. Don't worry, I knew that this was going to happen. Yeah, I'm going to say that too many times for you to believe me anymore. So what we can see is that our sprite render has brought in the spaceship. We can then further color it, so I can make my green spaceship red if I really want to, but I'm going to leave it like that. And it's very tiny within our scene. Now there's a couple of ways we can rescale this. We can just do exactly what we did with the background and basically just grab the corners and then made it massive. Or what we'd have to do is then, if for example, I'm just going to do this quickly, if I then brought in this spaceship and this one, and I wanted to resize all of them, I'd have to select that one, resize this, make it bigger, and so on and so forth. But that takes time and that takes effort. And what we want to do is we want to do things quickly in Unity. So we're going to select the spaceship sprite sheet. So like we have at the top here, we have all of our sprites underneath the sprite sheet. We're going to select that. And we're going to go to these settings in the top right-hand corner. It says sprite, multiple, and other things. We have one thing called pixels to units. So in Unity, we don't have a thing like meters or centimeters or feet or something like that. We have units, which is kind of like okay, if I make like a simple cube, just for example, this cube is 1 by 1 by 1. And if we imported in a texture that's 100 units to 100 pixels to 1 unit, basically it's going to be the same scale as this cube. So you can so if you really wanted to measure out exact platform widths and stuff like that, you can use that. So what we're going to do is instead of rescaling things all individually, we're then going to select our spaceships. We're going to go to this top right-hand corner, and we're going to say change the pixels to units from 100 to a low number. So basically, all of our sprites from sprite sheet are now going to be much bigger. So we're going to change this from 100 to 30. So they're going to be just over 3 times as big. And one thing we have to do is we have to click Apply. And what you can see is in our little game view, is our spaceship is actually at the size that you want it to be. So imagine this on a mobile phone, like a Windows phone, which I'll be building to later on. Basically, the spaceship's going to be like that big, which you can see in the editor there. And what I want you to do is I want you to select your spaceship with the scene view and position it somewhere at the bottom. But we come into a bit of a problem where basically our spaceship just disappears. Does anyone else get that? When you move it around, it just disappears from the game view. So there's a couple of things that we need to do. So one of these things is select our camera and have a look at it. So I'm just going to put mine to 3D mode, for example. So our camera is in perspective mode. Basically, it's like a cone. So we all have, both of our eyes, our cameras, which all have perspective mode. We all have a cone. I can tell that Nick, sitting over there with his Unity t-shirt, is much further away because of the perspective I'm looking at him. Whereas you, my friends, are much closer because you have a closer, you're basically closer to me. And it's kind of like a cone view. So what this sprite's doing is it's basically the sprite's so close to the camera that as we move it, it's going to move a huge amount. And that's not really how 2D games work. So games like Candy Crush or games like Angry Birds or Bad Piggies and things, they don't work on a perspective thing. They're basically everything is flat, all of them all within the same workspace. So what we're going to do is we're going to say to our camera, we don't want you to be a cone anymore. We don't want you to be like this big pyramid. We want to go over to the projection, so select the camera, and we have all the camera's properties. We want to click perspective and change it to orthographic. So what you'll notice when you change to orthographic is basically it's now a really long tunnel. So when we have our really long tunnel, basically everything is the same size. So for example, Nick, even though you're so far away, you're going to be the same size as you, my friends. So basically, yeah, everything is going to be all flat within layered on top of each other as opposed to based on different distance. And now the Microsoft guys are following along with this, right? Yeah, they're nodding. That's cool. So what you can see here is we basically have our little sprite. If we go into 2D mode, we can select our sprite and move it around within our scene and position it somewhere. So the end game that we're going to make is have our little spaceship at the bottom. So our spaceship's going to move left and right based on arrow keys, or if we tilt like a device. When we hit a button, it's going to fire a missile going up like a rocket. And we're going to have a series of asteroids which actually look like burnt pizzas, basically tumbling from the top and basically falling down for you to shoot. So that's what we're going to do. So basically what we're going to do is not open up mail. Yeah, force quit that. Okay, cool. Goodbye. So what we want to do is we want to select our spaceship and position it somewhere along the bottom because it's been moving left and right. A bit like Space Invaders or a game like that. Awesome, cool. We now have a spaceship. And what I want you to do now is I want you to click the play button and see our very beautiful game in action. This is shippable now. We can then push this to the Windows Store. So we're now going to have hundreds and hundreds of games of just this very nice wallpaper already. We have no interactivity. I can push all the buttons all day, but nothing happens. We've got two things rendered. So now we come into a problem with 2D games. And one problem with 2D games is things on top of each other. So Angry Birds is actually probably one of the best examples of this. So in Bad Piggies, we've got a series of layers. You can see the little green background there, which is going to have the sky and hills. We then have got some detail in front of that. We've then got sort of the back of the caves in front of that. We've then got the caves and the pigs and the TNT in front of that. And I think at one stage there's even like, on worms, there's wind rendered in front of the worms, and there's like oceans, and then there's GUI and stuff. Basically, you have this far depth of all these different layers, basically stacked on top of each other like sheets of paper. And in Unity, you can basically specify what's rendered in front of certain things. So I'm fairly sure that in a game like, you all played Limbo, and you'll have the little guy walking through the forest, and then you pass in front of trees and things. So basically, the developer has then rendered the sky in the background, then rendered some caves and trees, then the character in front of those, then some trees and sort of things in front of that. So there are basically lots of layers all sandwiched up and stacked on top of each other. So what we can do in Unity is we can basically do this sort of thing. Hang on. Unity is now... Okay, cool. Wicked. So what you'll notice is if you select the space layer or the green spaceship layer, in our settings, as well as our space being pink, we now have a sorting layer. So a sorting layer is basically saying which group is this going to be rendered in. Is this going to be rendered in the background? Is it going to be rendered in the foreground? Is it going to be rendered in front of the foreground? Is it going to be rendered in front of the foreground's foreground? So on and so forth. You can basically say which group it's going to go to. And I have a slide just as a little example. So you're making a simple platformer. You could have a background layer, which is sky and clouds and those sorts of things. You could have a foreground layer, which then has character and terrain and pickups and things jumping on top of other things. And then you could have a front detail layer, for example, a layer rendered in front of that of plants and trees. So your player is passing in between those things, in between the sky and the clouds and the plants and the dust and things in front of that. So what we can do is we can group these things. And then if, for example, the player reaches a point, you can then say the player is now in front of the plants and basically switch these layers in between each other. And the way that it goes is it renders the first thing, then the next thing, then the next thing. And basically it goes from back to front. So that's what we're going to do now. So what you'll notice is, Unity is massive. Cool. What you'll notice is that when we select our background space, it shouldn't go to... When we select our background space, we basically have a sorting layer, and that sorting layer is default. And if we select our green spaceship, or orange spaceship, or whatever color spaceship, we basically have it's on default as well. So when you bring in sprites into Unity, they're all on the same layer. They all have an even ground. So what we want to do is we basically want to say, we don't want them all to be on even ground. We want them all to basically be at the same level. So what we're going to do is we're going to click Add Sorting Layer. And we have a window here which basically has tags, sorting layers, and layers. And underneath sorting layer, you see we have default. So this is where you add those extra layers. So like in my slide here, we've got a layer called background, foreground, front detail. Basically, this is where you set all these different layers, and you basically say which order for them to render in. So what we're going to do is, just an example, you can call these layers anything you want. I mean, I could call this, for example, background space. Actually, everyone make a background space layer. We're then going to have a foreground main layer. So this is going to have our spaceships and our rockets and all these things. You can call them anything. I could have a sauna layer if I really wanted to, because I know you guys love your saunas. I could have a, I don't know, all sorts of bits and pieces. And let's delete those. So we have a background space layer and we have a foreground layer. The way this is going to work is it's going to go default, background space layer, then foreground layer. So we always want our spaceships and rockets and things to be in front of our space. Everyone okay with that so far? Have you got that all set up? Awesome. Cool. So if we select our background space layer, and I zoom in here, sorting layer, if we then click that little drop-down list, basically now you can then go from default into background space. So if you select background space, our background space layer is now rendered in background space. And I've just said background space again many, many times. If we select our spaceship layer, you'll notice our spaceship is now lost behind our space. So what we can do now is with our spaceship layer, we're going to change the sorting layer of that into foreground. So now our spaceship has basically gone from background to foreground. So now wherever our spaceship is, it's always going to be in front of those layers because it's now childed to that. So whenever we bring in our asteroids or our rockets, we're not going to set them to be rendered in the background layer. We're going to set them to be rendered in the foreground layer. Everyone okay with that so far? Wicked. Cool. So, yeah, we just rendered a spaceship in front of a space. So what we're going to do is we're going to select our spaceship and position it. So the next thing that we're going to do, how are you doing for time? Is there lunch now or like in half an hour? Okay, cool. So what we might be able to do in before lunch is actually get our spaceship flying around. So what we have with our spaceship is currently it's just at a position within our scene, and it's just got a simple sprite render to say, this is what it looks like. Currently it can't move, it doesn't have any controls. 50. Okay, that's cool, we've got plenty of time. So what we can do is we can add in components to basically say, this now has physics, this now can be moved, this is now bouncy. You can basically bring in all of these things. So what we're going to do is underneath in this list, remember that this is a description. So if I put on a hoodie this morning, I would have had a component of red hoodie, for example. Probably change the color to pink because you guys love the color pink, right? No, no one likes pink here, right? So what we can do here is we can then say, as well as it has a position within our scene, and as well as it's being a sprite, we can click Add Component. And in the little drop-down Add Component list, we can basically pick what we want to add. Do we want to add an effect, physics, audio, rendering, basically any of these things. So what we want to do is we want to go to Physics 2D. So if you select Physics 2D, we basically have a drop-down list of all the different types of physics we can do for our 2D elements. So beforehand, we had a physics, and that was the only one we had. And underneath physics, we had all of our 3D physics. So, for example, 3D boxes, 3D spheres, 3D cars, all sorts of these things. Whereas now we have a split. We have 3D physics and we have 2D physics. And what we want to do is we want to say to our spaceship, we want you to have some 2D physics, and we want it to have a rigid body. So now our spaceship should have a position, a thing to say to the camera what it looks like, and a rigid body. And that's pretty much the bread and butter of Unity, adding on components and building up what your object looks like. Cool. So anyone who is a Unity guru, tell me what a rigid body is or what it does to an object for a funky hat. Go for it, Pixel Man. Spot on. If we have any hats, we'll probably give them one. Oh, they're going to get one now, so they're super efficient. So yeah, basically making an object a rigid body or adding that component basically says you now have gravity, you now have a mass, you now fall, you now bounce off of things. If I picked up this glass and dropped it on the floor, I'm not going to because I'd have to clean it up. Basically, this glass is a rigid body to say it now falls, it now has a gravity, it has a mass. It's going to have a less mass than the floor, so it's going to fall and it's just going to shatter. So those of you who basically didn't take physics or didn't enjoy physics too much, like I didn't when I was younger at school, this is where physics come into play, and I highly regret that. So yeah, kids stay in school and learn physics if you want to make games and stuff. Or you don't have to, you can just add rigid bodies to stuff. So what we'll have here is we have a couple of things. So like Mr. Pixel basically described, he's now wearing his hat. It's not that cold. Basically, we have a load of options. We have mass. So if we had, for example, if I made this glass and this table in Unity, this glass would have a less mass than the table, because obviously, if I drop the glass, it's going to have a less mass. It's not going to push the table. And we're going to leave the mass at 1. So drag is basically how much drag it has. So if you think like you're walking in the wind pushes against you and stops you from walking so fast. Or you're driving a car and you've got lots of wind basically coming at your car, you're not going to be able, it's going to be more of a push. So drag is kind of like how much friction it has, that thing, for moving. Gravity scale is basically how affected by gravity it is. So now if we take our spaceship and we run our game, ready for the greatest game of all time, our spaceship now just drops. It's not very interesting. If I just pick it up here, I could rotate my spaceship. Basically, our spaceship has a gravity of 1, gravity scale of 1, so it's going to fall like that. If I change this gravity scale to, someone shout out a number bigger than 1, any number. Not 1,000, okay, 1,000, because someone said 1,000 yesterday. Yeah, you didn't even see it. It was that, okay, 5, that's probably a bit more realistic. Basically, it's going to have a great amount of gravity. Whereas, for example, if we change gravity to 0.1 instead, gravity is going to build up very slowly over time. So this is kind of like a bit more spacey, as opposed to 1, which is kind of like realism, I guess. Like realistically, if I drop something, it's going to move like that. Let's test this. No, I'm going to. This is when the guys from the Adams bar are like, oh no, start throwing glasses and things. So that's cool. So when I started learning Unity a couple of years ago, I found it really useful. Like the main thing that I found so beneficial is basically experimenting with the engine. So I used to just add a component. These are on my Friday evenings, my Saturday evenings. So you see how wild I was as a teenager. Basically, I'd go in and I'd say, what is this mass like if it was 5,000? What is this mass like if it's minus number? Oh, it can't be a minus number. Cool. What is this mass? What is this gravity like if it's like 1 billion and I try and push it through a block? Let's see what the block happens. Does it blow up or does it fly off? So what I found useful in learning Unity is basically just experimenting with all these different variables and different components to see what they do and how they work. And Unity has tons of these things. So basically, if you click component in the top corner, you can see we have meshes, we have particle systems, we have trails, we have lens flares. So if anyone wants to make like a Star Trek J.J. Abrams game, better than the one that was on Xbox 360, that's all I say about it. Cloth, you could have flags and things. You could basically just play around with a lot of these components. You could have AI and audio and things. You could have a reverb zone. So if you had a cave in a game, you could have an audio sound sort of echo off different walls and things. So Unity is very good for basically experimenting and building up your game from these components and learning about exactly what they do. So what we're going to do now is, if we started playing our game, so say like someone's bought our game from the App Store, 69p or 99p or £1.90, they boot it up, and the first thing that happens is our spaceship drops off the screen. They're probably going to 1-star rating us. So what we want to do is we don't want it to drop off the screen, but we still want it to have gravity. So I'm going to change the gravity scale down to 0. Because what we're going to do in code is we're basically going to say, when the user pushes right, we're going to apply gravity, or we're going to apply a force or a velocity to the right or to the left. We don't want our player to instantly get dropped, but we still want a level of gravity. So we have a couple of options here as well. We have fixed angles, so if we don't want our sprite to rotate at all, so this is more useful for like GUIs and things that are bolted on and straight. Collision detection. You have lots of fun things to play around with, but we're not going to change that. Basically, change the gravity scale to 1. And what we have here is when we run our game, our ship isn't going to move, but it's still being affected by physics. And if we had, for example, another ship fall down, it's going to collide and push it out of the way. But it's not moving. That's what we're going to do via code. So if we go out of that, we're then going to add a component to basically animate it, or basically move it. So we're going to write all of our script in C#. So who has written C# before? Okay, so we have some gurus who can take over for me if I lose my voice, right? No one looks very happy by this idea. Okay, that's cool. So we're going to write all of our scripts in C#, like so. So what I'm going to do is, in our project at the bottom, I haven't written any scripts because I'm mean and make everyone write everything from scratch. We're going to create a brand new folder at the bottom here, and we're going to call this folder scripts. Then inside that folder, we're basically going to create a C# script inside that. So you'll notice we'll have an input field saying new behavior script. And we're going to call this something very obvious. So spaceship control. And we then have a script called spaceship control. So currently that's just sitting in our project. It's not going to do anything. It's just sitting there dormantly. It's not going to apply to anything. It's not going to do anything. So what we need to do, you need to add it as a component. We need to say spaceship control, you're now on the spaceship, you can now move this spaceship. That's kind of like what Unity is going to tell the spaceship to do. So if we zoom out, what you can do is select our spaceship, and what you'll notice here is we have an option of add component. We have this big button. We're going to click add component, we have this list. So if we go through here, we can go down to scripts. If you select scripts, it's going to find all of our scripts in a project and say, what do you want to add to the spaceship? In this case, spaceship control, and we're going to select that. And what you'll notice is that our list is basically building up for our spaceship. We had position, we have sprite renderer, we have rigid body, and we now have some code to say, whatever code we write inside this script, we can now move our spaceship. So that is cool. Awesome. So what I'm going to do now is write a bit of script, and then I think we eat pizza. I really hope they book pizza, because otherwise I've been promising something many, many times, and yeah. So just double-click the script. So when you download and install Unity, it installs a text editor called MonoDevelop, and this is already hooked up to Unity in the fact that it does auto-type. So as I start typing, for example, rigid, it's going to automatically say, oh, are you referencing rigid bodies? What do you want to do about them? Do you want to add a force? Do you want to add a spin? Do you want to increase the gravity? All sorts of things like this. Okay, file open. Right, okay, we're going to have to do this the long way. So what you can do in Unity is you can double-click the script, and basically it's going to automatically open up in MonoDevelop. Now, MonoDevelop is basically Unity's scripting sort of like editor. So you can use whatever you want to. If you want to use Sublime, or you want to use Xamarin, or whatever it may be, or even Eclipse if you want to, you can use those. But basically, MonoDevelop comes with Unity, so when you download it, it comes basically paired up with it. And it does do autotype. So if I write rigid, it's then going to say, oh, do you mean rigid body and things like that. So it's very useful for learning how to script because it's going to recommend things and basically hold your hand and help you along the way. So I have times when I script anything, and I'm using UC for like 3 years, I script anything, I'm like, oh, I forgot what the next bit is. And then mine says, aha, this is what you mean, or this is what you probably mean, or this is maybe what you want to mean. So Monzo is very useful, and it's very tied well with Unity, and it always updates along with it. Cool. So what I'm going to do is I'm going to actually I could probably edit the view of MonoDevelop itself. So we're going to write some very simple code to basically move our spaceship left and right, and then we're probably in like lunch in like 2 minutes or so. So inside this class here, most of you have written C#, but those of you who haven't written C# before, we're using the Unity engine, and we're using systems.collection. That basically exposes Unity's API when it's compiled within Unity to basically say, we can use all of Unity's functions, we can access all of these. We have our class of spaceship control, and we have 2 functions here. We have one called void start and one called void update. So anyone, trick question, what do start and update exactly do? Those who put your hand up and said you know C#. Or does Pixel Guy want to answer this? You already have a hat. Okay, so void start runs at the very start that this object comes into play. So when the game begins, for example, you want to re-heal the player's health, set their points to 0, start playing music, things like that. So void start is basically the setup. So if I just write some like really simple code comments to say, set up the scene, refill player health. It could be something like in Angry Birds where it positions all the pigs. So like positions pigs. Cool. It could be something like Minecraft when it generates all of the terrain, all the world. It's basically all your setup and building up your scene through code. Void update runs every single frame, and basically what it does is it says every single frame, what is the player doing? Is the player run out of health? Has he reached the end of the game? It's constantly going through these series of rules saying, has this happened yet? No. Has this happened yet? No. Has this happened yet? No. Oh, this has happened. Okay, now load up game over screen, or now load up the high score screen, or now load up you died screen, or whatever it may be. So void update is where we're going to do controls in, because as it's checking every single frame, it's basically saying, has the player pushed the pause key yet? Or has he pushed up, down, left, right? Where is his mouse? It's basically constantly checking. It's like if I told you to draw on an Etch-a-Sketch a picture of a dog and then basically shake it and then move it slightly running a bit right and then shake it and running. It's kind of like automatically doing that. It's finding out where things are in the game and what you're currently doing. So we have void start and void update. Now for the script, I don't want void start at all. So I'm going to delete void start and get it out of there. But I do want void update. And we very nicely package in a little comment to remind you, update is called once per frame, which is cool. So what we want to do is we want to tweak things in the editor. And one of the great things about Unity is basically it's friendly towards artists, programmers, designers, people who don't even do any of those things. They just want to look at the game. It's very friendly and very accessible. So for example, if I showed my my 70-year-old Nan this spaceship, she'd know instantly what mass, what gravity is, all these things. Well, okay, maybe not is kinematic or something like that, but she'd probably have a good guess, what all these things do. So the way that Unity is made is that it's friendly to all sorts of people. So if you're an artist, you can customize the editor and basically cater for this. So game designers, in my experience, don't tend to like code. They tend to look at it and claim it looks like the Matrix or something like that. Or, yeah. So what we can do in Unity is we can basically say, inside here we have a variable, so we could have, so if we all write public float speed, that is a simple variable to say we will have a float, so that could be a number with a decimal, so this could be 0.3 or 0.5 or 0.1 or something like that. Now, in making that variable public, if we go back into Unity, basically, it's now going to add this right here. So we can pass this over to the designer and say, set up a whole load of values, and we can say, try out the ship at, for example, a speed of 4. Speed of 4, yeah. Speed of 5, speed of 1 million, a speed of perhaps -5 if you want to drive backwards or things like that. Basically, the designer can go through and tweak all these variables how they want it to be. They don't have to necessarily go into the code, possibly mess up all of your script, and yeah. So let's zoom in a little bit more. Okay, so we now have a variable, so we can play around with how fast a ship's going to be. So what we're going to do inside update is we're going to find out how the player is pushing left or right. And later on, they're going to script in basically tilting if we get around to it in time. So in Unity, basically we have Windows. In Unity, we have an input class. So that input class basically gets certain keys. So if you go to File, you go to Edit, Project Settings and Input, this kind of runs in the background. It's already in place. So these are currently a bunch of things. So for example, when we say if Fire 1 is pushed, Fire 1 is going to be a left mouse click, or it's going to be left control, or things like that. If we push, for example, jump, that's going to mean the spacebar key is pushed. Now, if we wanted to add extra things, so for example, pushing P basically means you've paused the game or something like that, we can then add in an extra axis to say, when we push P, it means we have paused the game. Now, Unity has some pre-built-in ones, which basically, as we made this new project, it's going to say, we have a horizontal axis, and we have a negative button of left and a positive button of right. We also have an alternative negative of A and a positive button of D. So this kind of like works like a joystick. So if I had my phone like this and it was a joystick, basically what it's saying is when we push the right key, our joystick is going to go from 0 towards 1, and it's going to stop at 1. When we push the left key, it's going to go from 1 to 0, 0 to 1. So those of you who used to have a joystick, we used to have a joystick, flight simulators and arcade games and things, it kind of works like that. So what we're going to say is it's at 0, then when we push either left or right, it's going to find out which one we pushed, and basically move our object based on that value. So it's either going to be 0, 0.1, 0.2, so on and so forth to 1, or 0, minus 0.1, and so on and so forth to -1. So we're going to write a couple of lines of code. I think I can smell some cheese. And yeah, smell cheese. We're going to write one line of code, and then we're going to come back to this after food. So we're going to write float h. So we want to basically find out whether it's 1, 0.3, or something in this tilt. Equals input dot get axis horizontal. Cool. And save that. So every frame it's basically going to say, are we pushing the left key or are we pushing the right key? That's simply what it's doing. And it's accessing that input area. It's getting the axes that we've currently got for horizontal, and it's doing that. So we've now got left and right controls, and it's basically saying, is this 0, is this 1, is this -1? So -1 is left, 1 is right. Everyone okay with that so far? Some of you already know C#, so you probably already know this, but yeah. Rather than me just typing it and then you guys guessing what the heck I'm doing. It looks like I'm making things up. So it's everything's on the table, I guess. 5 minutes? Okay, in the next 5 minutes we could have our spaceship moving around. Do you guys want to go for lunch now and run and get pizza, or do you want to have a spaceship flying around? Which one's more awesome? Flying, right. Okay, so I'll write this code now. If you want to head off and get lunch, I'll basically leave the code up, so as people are having lunch, you can then come back to it or edit it. We're going to do a simple if statement. So you're basically going to say if h, so this value that's either between -1 or 1, is less than 0, so that means our joystick is going towards the left, then we're going to do some code. We're basically going to say, spaceship, go left. Else, if our joystick is greater than 0, so it's going to the right, we're then going to do a different piece of code. So we're just doing a very simple if-else if statement. And I'm going to code comment in here. That's going left. Hooray. Pizza is here. And this one's going right. Cool. So what we're going to do now is, we're just going to do that simply. And I'm now going to write another function. So this function is going to sit outside update. It's not going to be updated every single frame. It's going to be called when we say, go to this function and run it. And this function, we always start a function or a method with void. And then we're going to call this apply force. And move the ship in the direction pushed. Cool. So apply force. So what we want to do is we want to say, when we push the key left, we want to go to apply force, but say, move it to the left. So basically we're using the same function, but we're going to swap out what that function is doing. And it's very simple. We just write apply force underneath both of these. So we're using exactly the same bit of code. We're doing something very clever in code, and this is what you should be doing anyway, is basically reusing functions and reusing things. Because if I was to write out lots of individual bits and pieces for pushing left and right and things like that, that's going to be, you're writing twice as much code, plus also it's going to be a nightmare later on when you have to like compress it down. Whereas what we're doing is we're using the same function, and we're just going to put it inside the brackets, we're going to pass it which direction we want to move it in. So if we want it to go right, we basically need to tell it vector2.right. So we're basically going to say, go to this function and use vector2.right. If we want to move it to the left, we're going to say vector2.right, but we're going to put a minus sign in front. So minus sign is basically going to mean the opposite. Currently, vector2.left doesn't exist in Unity, and it should do. Nope, it doesn't exist in Unity, so you notice my developers basically put up like a big red bit of text to say, nope, do not want. We're going to say vector2.right. So what we have to do is we have to say minus. So it's going to go to apply force, and it's going to say apply force to the left, and it's going to go to that one and say apply force to the right. So inside this function, now what we're doing is as we're referencing this method, and we're passing in which direction we want to go, we basically have to catch it on this side. So if I made a paper airplane and threw it to, who am I going to pick on? Microsoft guys. Yeah, I'll pick on you. So I made a paper airplane and threw it to you guys. Basically, you've got to catch it on the other end, or you can not catch it. You know, it's up to you. But I want you to catch it because I don't want to poke your eye out. So basically, what we need to do is, as we run this method, as we're sending the method a direction, we need to kind of catch it on the other end. We have to tell this method what we're going to catch. So in this case, we're going to catch a vector2. So vector2 is either left or right or up or down. And we want to basically store that as a variable of a direction. So we're basically going to say, get this bit, and this is now a direction. Then, in the code, we can basically say rigid body 2D. So we're going to access the rigid body. We know that it has this rigid body. We know that it's affected by physics. We're going to add a force. Then inside here, we're going to tell it which way we want the force to go and with what power. So in this case, we're going to take that direction, and we're going to multiply the direction by speed. So for example, if our speed was, so say like our speed was like 500, and then our direction is right, it's then going to apply a speed of 500 to the right. It's that simple. It's basically going to say, go to the right by a speed of 500. Now when I push the left key, it's then going to go to this function and say, we're no longer going right, we're now going left. So it's then going to say, speed of 500 to the left. Very simple, very nice and easy. Of course, if I wanted to now go up, I don't have to write another function. I can then just say, if I now push up, go to this function and just use exactly the same piece of code. Nice and simple. So now with that all written down, go into Unity, tell your spaceship to have a particular speed. Try not to have 10 million because you will not see it. It will disappear, and the Microsoft guys are about to do that. And test it out and push left and right to move your ship to go left and right gradually. I think the sweet spot that we found yesterday for the speed was something like 5 or 6. I'm not sure. Let's have a look. And so now what we have is if I push left, it's basically going to apply a force of 5 to the right, or left, oh god. But now because we're using gravity, basically our ship is now, it's going to drift and eventually get to a stop. Because basically it's going to go eventually. So what you might need to do is you might need to play around with it. We might need to say angular drag or linear drag basically increase. We're going to say linear drag, you are now a value of 1. So now we have some form of wind fighting against it. So now it actually does drift down to a stop. So we now have you can imagine this as like hitting a spacebar, pew pew pew, firing lasers and blowing up asteroids which look like burnt pizza. Cool. Has anyone got any questions about that stuff so far? Some of you are pro Unity dudes, and you've already like, yeah, this is easy. I can just write all this left and right code. But hopefully, if you have any questions, I don't bite at all. Yeah, just come and ask. Cool. Awesome. So that's probably a good finishing point. And then when we come back, I'm going to be doing like a 45-minute talk, basically showing how to build to Windows 8 and Windows Phone. So it's kind of like a bit of a tangent, so the porting guys can come in and see that. Then perhaps like we have like a little bit of a break, like 5-10 minutes, to get back into things. And then we're going to have missiles, we're going to have asteroids, we're going to have building to platforms, tiles, logos, all sorts of fun stuff. So yeah. Cool. Awesome. Thank you.